Okay, brief introduction, brief lesson. We are going to talk about power and radical functions. Today is the only day that we get to use Desmos. The rest of the unit is not Desmos. The rest of the unit is going to be sketches because these graphs become so involved, it is impossible to make them accurate by using pen and paper. So let's go ahead and get started. The first thing that you see are power functions where nothing is added or subtracted. So they're all just one term here. And what I want to point out before we go any further is, you guys already know this, but I just want to remind you because it's very important. Remember, all positive functions are going to be up on the right, and I'm talking about the right side of the graph. And of course, all of your negative functions are going to be down, and I'm talking about the right side of the graph only. Okay, so there's a couple of other things I want to point out. If you look at this picture, we've got something that looks like a parabola. It's really going to be anything raised to an even power. You have an upside down even power, and then you have odd powers. So if you notice here, the end behavior is the same. Both of the arrows are pointing up. Both of the arrows are pointing down. The arrows are going to be pointed in opposite directions for all of your odd powers. Lots of information here. Here's some things that I really want to point out for you. All of your monomial terms are always going to go through the origin. It doesn't matter if it's an even function, if it opens up, if it opens down, if it's an odd function. If there is nothing added or subtracted, it is always going to go through the origin, one term. Some other things I want to point out. If you notice down here, we have our end behavior. So remember right here, they are both approaching the same thing. They have the same end behavior. Same if it's opening down. If it is an even function, the end behavior is the same. And remember, if it's an odd function, it is not the same. But what's pretty important here is that your domain and range are negative to positive infinity. So I'm just going to write that right here. Don't forget that negative sign. All right, so let's go ahead and start graphing these. Graphing is heavy, like I said earlier, but the cool thing is it's just a sketch. So I kind of need to change the directions on this. Guys, even though we see grid lines, just pretend the grid lines are not there. For right now, just pretend we see an x-axis and a y-axis. So, like I said earlier, this is the only time we're going to use the calculator to help us shape this graph, just this section right here. So, I'm going to go ahead and pull up Desmos for us on 11 or on 10A and 10B, also 11A and 11B. You guys are going to have to submit this on your own. This is actually part of your notes. There's no homework. You're just going to turn this in to me when you turn in your notes, and I'm going to remind you about that later. And again, I'm going to use Desmos. You don't have to pull it up. I'll have it on the screen, but when you do this on your own, you're going to have to use Desmos on your phone. All right, so for this first graph, I already have it ready for us. Let me find it. Here we go. So for this first graph, this is 10a. Notice we have 1/2 x to the 4th. It is a positive function. It opens up on the right, and the degree is even. So let's just go ahead and shape the way we want that graph to look. So guys, literally, it almost looks like it's a parabola, but since it's to the 4th degree, it's all kind of flat down there around the origin. That's all I want you to really remember for right now. However, lots of attributes now that you are in the second unit of pre-cal. You remember your domain is going to be negative to positive infinity, but your range is not. Your range is going to be from 0 to infinity. And guys, don't forget, we need to identify the x and the y-intercepts, which is so easy on this page because the x-intercept and the y-intercept are the same thing. So remember, that's going to be 0, 0. And then for the sake of practicing, let's remember how to write where it's increasing and decreasing. So it is decreasing from negative infinity to 0, and it is increasing from 0 to infinity. One more thing I want to talk about is end behavior. Your end behavior is the same. They're both going up. So to be clear, I'm going to write that in my notes, but it is the expectation that you understand this on tests and quizzes. Okay, now let's go ahead and take a look at number B, letter B. Letter B is a reciprocal function in disguise. You must remember there is no such thing as negative exponents. They truly do not exist. If you see a negative exponent, it's just on the wrong side of a fraction bar. So this should be written as f of x equals 3 over x to the 5th. The 3 didn't have an exponent, so it's going to stay there, but that x that had the negative 5 has to get dropped below a fraction bar. Guys, that's a reciprocal function. It's going to look a little weird, but remember, that is still an odd exponent. Let me pull up Desmos for you and see what this looks like. Oops, I hit the wrong button. All right, so if you notice, we do have an odd exponent. You do have a asymptote because we had to put that x down there below a fraction bar. But I just want you to remember, if that asymptote did not exist, this would go from negative infinity to positive infinity. So because it has an asymptote, it just has crazy looking graphs. I do want you to recognize that it does have a branch up on the right, which totally makes sense, guys, because the a value was positive. We had a leading coefficient that was positive there. So when we sketch this, you do need to use a red pen. Go ahead and block out those asymptotes and go ahead and remember to label them. So remember, y equals 0, x equals 0. And guys, just sketch your branches. Don't worry about finding any points. So you're going to have a graph, remember, up here, because it was up on the right, because it was positive, and then there. So let's go ahead and talk about some attributes here. Your domain is going to be negative infinity to 0. Then we're going to pick up from 0 to positive infinity. The range is going to behave the same way. Negative infinity to 0, and then 0 to positive infinity. Your x and y intercepts, you don't have any, guys, because the origin got blocked out because it was a reciprocal function. So the x and y intercept is none. And then for increasing and decreasing, remember, it would be from positive to negative infinity, and it would behave differently if it was not a reciprocal. So for increasing and increasing, just skip that for now. No increase or decrease on reciprocal functions. You do not have to worry about that for now in this unit. You will later. We'll skip it though for now. All right, let's go ahead and turn the page and talk about roots and radicals. So for this right here, guys, what you need to remember is a very important exponent rule. Please write this down. Anytime you take a root that has the exponent inside, that is actually a fractional exponent in disguise. So remember, that is called a fractional or a rational exponent. Okay, So again, for these, let's look at the chart. Chart's very important, guys. Let's go ahead and read what it says. First of all, I don't want to shake this. You have an even root and you have an odd root. Notice they kind of behave a similar way. You still have negative to positive infinity for your odds. Also notice it is restricted because remember you can't take the root of a negative number. Alright, so let's go ahead and talk about this table. First of all, again, plain roots. Remember, we're still talking about monomials. This is just one term. It goes through the origin. Also, take a look here. You have an extreme right here for even roots. You're not going to have an extreme for your odd roots because it's negative to positive infinity. But you do have an absolute minimum here for your even roots. Again, you can't take a negative number, so that's why that exists. So one more time, guys, we're not going to graph. We're just going to sketch these out. So again, just pretend that you do not see any crazy things going on here. Now, when it comes to Desmos, remember you have to turn in the very next page as part of your completed assignment. When it comes to Desmos, we're not going to be able to put in a third root there. So what we're going to have to do is we're going to have to make some changes in the way this looks. We're going to have to remember this rule. So on A, when I go to grab this in Desmos, guys, look how it looks. I leave the 2 where it's at. All this other stuff, the inside, I write in parentheses. It's going to look like this. The outside, see that 4? It becomes a fraction. So let's practice writing this one. Everything on the outside stays the same. That's like a -1. I'll just write the negative. And then see that stuff underneath the cube root symbol? I'm going to put it in parentheses. And then that's an index of 3. That's going to go on the outside as a fraction. You have to do it like that for Desmos. If you look to the other page, you got some crazy roots going on over there. You have to write them like this. This is important. All right, guys, again, I have these already pulled up. Let me go ahead and find it for you. So we are on 11A. Let me find 11A. And there it is, guys. Remember, it was just the 4th root. It kind of behaves like a square root function. And if you notice, I already set it up the way that I'm asking you to do so. So make sure you write it correctly. And then when we go to graph it, just sketch it, guys. Just sketch it. So this graph is going to shoot off like this. And then remember, it has an absolute minimum at 0, 0. Your domain is from 0 to positive infinity. We get to include 0. And then your range is going to be the same thing. Now, if I describe the behavior of this graph, all I can say is that it's increasing. So this graph is going to be increasing from 0 to positive infinity. All right, now let's take a look at this craziness over here. So for this graph, let me go ahead and pull it up for you on Desmos. And open graph. Here we are. Oops, I forgot to put a square in that. Let me go ahead and type that in real quick. All right, so if you notice, this looks so crazy. Like it has a little hump around the origin and both sides point down. Notice the graph is down on the right, which makes complete sense because it has a negative in front of it, guys. So it is still going to have behavior that is different because you have a square term inside your parentheses here and you have a root on the outside. Let's just sketch this on our graph. So to sketch it on your graph, it is going to look just like this, guys. Again, just sketch it. Mine does not look good. If I could have a do-over, I would do a do-over. Just make sure that you have your graph pointing down and you have a hump over there right above the origin. So when we go to talk about what's happening with this graph, just remember that it does go on forever, and our domain is going to be negative infinity to positive infinity. All right, so let's go ahead and turn the page. And let's talk about your next page here. Cross out the word homework. It does need to say notes, guys. And a few things that I just want to point out for you on this is make sure you describe the domain, the range, any x or y intercepts, your end behavior. I'm just going to abbreviate that right there. And guys, also tell me where it's increasing and where it's decreasing. So when you turn this in on Canvas, this needs to be filled out for each one. Also, please remember this negative exponent, that's not happening. That's 2 over x to the 4th. This, the negative fraction's okay. It's just the exponent can't be negative. So this is 2/5, and then it's going to be times 1 over x to the 9th. Now, Desmos is going to be cool if you plug them in like that. You don't have to change where it looks like this. Remember, Desmos is not going to be good with a radical above this, but this is just a root of 2, and Desmos can handle that. Okay, make sure you turn all of this in, and then we'll move forward.